everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. We are going to discuss about the topic volume of your region using triple integration. So in this video lecture, we are going to discuss about first a definition of volume integral and a few problems based on volume integral. Definition of volume integral. First, what is volume integral? Volume integral, it's nothing but is the integral which is used to find volume of a particular region using multiple integrals. Then it is called volume integral. It is denoted by capital V if the region what we are going to find, it is in solid. The geometrical figure is solid, then it is contained in the region V. The formula is triple integral dx dy dz, that is, it is in three-dimensional x, y and z. The three axes are there. We will do the multiple integral, that is the triple integral, using we will evaluate the volume. If it is in Cartesian form, this formula to be used. Suppose instead of Cartesian form, if they are in cylindrical coordinates, then r dr, d theta, d pi, this formula to be used for polar coordinates in three-dimensional. So now here, find the volume of the tetrahedron bounded by the planes x equal to 0, y equal to 0, z equal to 0, and the plane is x by a plus y by b plus z by c equal to 1. So the question which is given tetrahedron, that means it has four planes. The planes, the face, they are in triangular shape. So that the geometrical figure, we are going to find the volume satisfying this plane conditions. So this is the plane condition which is given here. So according to that, we are going to draw the diagram, that is, so we can notice it here, the two axes are there. So the three axes, because as it is x, y, z. So this is the origin. So it is represented, it is named as x-axis, y-axis and z-axis. Now, we know it actually, it is given. We are going to the basic thing. Here from the origin, it cuts this y-axis at the point A and x-axis at the point B, and here z-axis at the point C. And we are joining the points. Joining these points, we are getting actually the triangle. So we need this, you can see the straight lines, the dotted straight lines. This is the complete region volume we have to find. For that, the method what we are going to adopt is, we are going to find volume vertically. For that, we are going to take a strip, that is, here it is there, that is A and B. This is in three-dimensional, that is, if you are seeing the surface, it is in xy plane, that is, this is the region, it is formed by x and y, x-axis and y-axis. So this what we have taken the vertical strip. It is in the xy plane starting, that's what it is here, and ending this complete the three dimension put together. The plane is x by a plus y by b plus z by c equal to 1. So we have drawn the figure, this volume to be found. Now, first this region, we can take it separately if it is there, how it will be. That figure also it is drawn. So now, before slide, what we discussed it, that is the size, we made it very small one, we kept it here. So now, the volume AB parallel to z-axis, it is clear. The figure what is there, it is parallel to z-axis. And this is starts from our xy plane, that is also clear. And it terminates here the three-dimensional xyz plane. So this is the plane for that. So the limits z, from here it starts with 0 and ends, this one ends up to this plane. So that is the reason here. From this we are extracting what is z. So when we are extracting, it is becoming x by a plus y by b equal to 1 minus, so we can see it 1 minute, z by c equal to 1 minus x by a minus y by b. From here we are extracting what is z equal to c of 1 minus x by a minus y by b. That's what it is written here. So the limits as it is xy this part. So z from here 0 to touching the plane, the limits are given here. Now the projection of the plane, that is a three-dimensional plane. So x by a plus y by b plus z by c equal to 1. In the xy plane, that is, if you are taking the xy plane, this is a triangle. That's what here we can see, the triangle OPQ. So the equation of the line PQ, which is obtained as it is in the xy plane, z equal to 0. There is no way the z-axis connected to this region, so z equal to 0. Even we can notice it here also, z equal to 0. This is our main, the question, the plane here, and this is three-dimensional plane. We have drawn the diagram, we discussed it. Suppose we want to, how this region, if we are taking alone, how the figure it will be, that we can see it. That is only the two-dimensional part, xy part only we are going to take. That is, here this is the origin, x, that is this part, the x is here. This is y part, it is written here, y is there. And the line which is closed, so we can see it. Here we are considering only X and Y, that is the reason OB, the Q of OB. There is no connectivity of Z axis here. And here the P, the Z, the coordinate is neglected. So P of A comma 0. So these P and Q joining, we are getting a line that we joined it. So now this is the region, the triangle which is formed by this PQ and joining this region. The lines which are here, the vertical lines dotted, this we have to evaluate. For that, we are going to take a vertical strip. That vertical strip we are naming as A dash and B dash. So from here, we know it, this is the horizon 0, 0. So this is the XY plane. Separately from this figure, we have drawn it, the XY plane alone. So this XY plane limits we want it. The limits are Y limit we want it. That is from 0 to, as it is, Z is 0. This completely it is vanished. So neglecting that, the remaining it is written since we are concentrating XY. Alone for that, the diagram which is drawn here. Now from this, to understand level more purpose, to how we are getting the limits of Y, how we are getting, for that purpose the diagram which is drawn here. So from which we will be getting the Y limits. So the diagram which is kept again. So this is our three-dimensional plane. So we are concentrating this diagram only XY plane. So this is missed. So now this is a vertical strip, A dash, B dash. So now OPQ, that is, which is in the region, that is the main actually three-dimensional what we discussed in that the surface part OPQ, that is a XY plane. That XY plane only here, the shape is triangle. Now the vertical strip, why we have to do? Because we want to know from the three-dimensional, the condition, the plane, this using Z limits we got it. We wanted Y limits. So separate figure we have taken XY plane from which we are going to extract Y limits from where to where. So it starts from 0 to 0. So Y from 0. So we can see it here. X-axis it starts. We can see the strip. It starts from X-axis and it ends with this line. This line, it's nothing but X by A plus Y by B equal to 1. So we can see it here very clearly, Y equal to 0, 2, from which we can extract what is B. So very simple way, that is Y by B equal to 1 minus X by A. So Y equal to B of 1 minus X by A. So from which we got it, we obtained it. What is Y? From where to where, it is very clear now. So the limits of Y also we completed. Now the leftover is limits of x from where to where. Now this is the vertical strip. The strip, the left side, that is 0, 0 is there. Yes, x is playing the 0 value. It starts from the origin to up to p it moves. Here our x is a. So the x limits are from x equal to 0 to x equal to a. So this is the figure. Once again it is kept here. Now we are going to concentrate the triple integral. The triple integral dz dy dx. So the limits we obtained it, that is z from 0 to c of 1 minus x by a minus y by b, and that is the innermost integration. The middle integration we are going to do with respect to y. Y limits are from y equal to 0 to y equal to b of 1 minus x by a. So the outermost integration is with respect to x. That is from 0 to a. Now we will evaluate this integral first with respect to z, next to y, the last one is x. So now we integrated this one. We know it, integral dz, it's nothing but z. That's what it is kept here. We integrated the innermost one, and the limits are the lower one is 0. The upper one is c of 1 minus x by a minus y by b. So we can see here we applied the limits, that is z place we substituted the upper limit. So it has taken this position here. This is the limit formula. This is the lower limit position. Substituting z place, we got the value 0. So we completed the innermost integration, integrated. We applied the both upper and lower limits. So after applying the c we have taken before the integral, anyway it is treated as constant. That is the reason before the integral we kept. So the leftover is 1 minus x by a minus y by b dy dx. Now this integral it is written, the c is written. Now here you can see it here, dy. So we have to do the integration with respect to y. This part we are taking as 1 minus x by a. So 1, otherwise separate also we can do it. If you do separate, y minus x y by a will be coming. This I will write it, y minus, because dy integral is y and x by a is treated as constant, into y. This only it is written here. That is x minus 1 minus x by a is taken here into y. This minus sign is as it is, and b is as it is. Integral of y dy, it's nothing but y square by 2. This is y square by 2. So we completed the integral with respect to y. So this is the integration we did. Now we have to apply upper limit and lower limit in the place of y. Here we have to apply, and this is the place we have to apply our upper limit b of 1 minus x by a. So now we can see it here. That is the previous step. It is kept again here. So the c is written as it is. This 1 minus x by a, it is written. This y place, we substituted the upper limit. This minus sign is as it is. And y square, that is, we are substituting the upper limit, this one, y square, so b square, and this is square 1 minus x by a, the whole square. This 1 by 2 is written here. So we substituted the upper limit. Anyway, the lower limit is 0. In the place of two terms we have, first term, second term, both the terms y it is there. So 0 into anything, 0 divided by anything, 0. That's what it is not written. It is not mentioned here. So we completed the middle integration with respect to y also. Now the simplifications we are doing before going to the last integration, that is outermost integration. So now here c is there. This is, we can see it here, b is there. Here b square by 2b. So if you are cutting here also, the top is becoming b. That's what it is kept, b as a common term. And this both multiplying 1 minus x by a, the whole square we are getting. This minus is kept as it is. Here also, no, we didn't take it common. The next step we are going to be, here it is written as it is only. And this 2 also written here. This 1 minus x by a, the whole square also written here. Now, here b is there. This is what I am circling. They are the common terms. So it is written here. The coefficient b minus b by 2. It's nothing but 2b minus equal to b by 2. So that's what it is written, b by 2. The c is written as it is. Now finally, our outermost integration we have to do with respect to x. So already the c is outside. Even b by 2 is also a constant. So we kept it put together bc by 2. Now final integration, we will concentrate for the outermost one with respect to x. For that, so we know the simple integration formula, that is integral x power n dx equal to x power n plus 1 by n plus 1. Fine. So the bc by 2 it is written. Here 1 minus x by a. Our n is playing the role n. So n plus 1, what we wanted? 3 we wanted. That is, we are getting 2 plus 1, 3. So divided by, so we can see it here, square dx, that is 1 minus x by a, the whole cube divided by 3 into x coefficient is nothing but minus 1 by a, that is multiplied here. This put together only, it has come here minus 3 by a. So we completed the integration part for our outermost also. Only the leftover is only limits we have to apply. So the limits applying here, this minus 3 by a is there. just we are bringing outside, it has become BC by 2 into A by minus 3. So put together it has become minus ABC by 6. Now this term only we have to apply the limits. The upper limit, when we are substituting here in the place x, a, so it is becoming a by a, it's nothing but 1. So 1 minus 1, it has become 0. This is limit to formula sign. The next, the 0 to be applied, that is our lower limit in the place of x. So we are applying in the place of lower limit. Actually, x place 0 we are applying. So this entire term is vanished. So 1 cube, it's nothing but 1. Already here minus sign. This put together, it has become plus. So we got it ABC by 6. So we solved the entire problem using triple integration. So the next problem is evaluate v equal to triple integral dx dy dz, where v is the finite region of space formed by the planes x equal to 0, y equal to 0, z equal to 0 and 2x plus 3y plus 4z equal to 12. So now this is the condition of for the plane which is given, that is the origin, and the three-dimensional plane which is formed also it is given. We have to evaluate the volume. So now the volume of a solid contained, because as they are in the Cartesian form, so we will take related to that Cartesian form volume formula, that is triple integral dx dy dz. So we have taken here the innermost one, we are taking z, that is from 0 to what we discussed in the earlier problem, the same similar manner, from 0 to from which this plane we will extract what is z. So 12 we are taking minus 2x minus 3y equal to 4z. So z equal to 1 by 4 of. So if it is only xy plane, then 2x plus 3y equal to 12, from which we can extract what is y, 12 minus 2x, that is divided by 3. Next, finally, 2x equal to 12, x equal to 6. It is written. Now, the innermost integration, that is integral dz dy dx. So the integral dz, it's nothing but z. So we have written here, the z is there. We integrated the innermost. So the limits are from 0 to 1 by 4 of 12 minus 2x minus 3y dy dx. Our dy is the middle integration. The final is x for outermost integration. So we substituted in this place our upper limit. It is substituted here. This is the formula minus, and z is taking the lower limit, the value is 0. It has become here 0. So innermost integrated, we substituted the limits, we got it. This is the result. that is 12 minus 2x minus 3y. This 1 by 4 we have kept just, that is the middle integration front, we have kept it. If it is that, here also we can keep it, nothing wrong in it. Anyway, they are going to treat it as constants. So now this we have to do it with respect to y. So this we have written as it is. Here 12 is there, integral dy, 12 into dy. So integral dy is y. This minus 2x is as it is. Here also integral dy, it is y. Minus 3 is as it is. Integral y dy, it's nothing but y square by 2. Lower and upper limit regarding y limits are put it here. So it is written here with the y limits. Now wherever y, we have to substitute in the place of y 1 by 3 of 12 minus 2x. So we will do the comparison of the previous step. What it is kept, I am putting the tick here. There is no changes as it is written. And 1 by 4 also. This 12 we kept it as it is. Here y is there where I circled it. So we substituted the upper limit. The 2x as it is. Here y is there. We substituted the upper limit. And here the minus sign. 3 is written as it is. Here 3 by 2. So put here is there. Y square. So here 1 by 3 of 12 minus 2x, the whole square is written. Completely upper limit we completed. Formula minus. The lower limit, in the place of y we have to substitute. So 1, 2, 3. So in the place of y, so everything it is getting vanished. So we got it, the lower limit is 0. Now we will do the simplifications where it is possible after applying this upper limit. We can see now. So this and this as it is, it has become 4. This term as it is, this put together it has become minus 2x by 3. And this is 12 minus 2x. Here minus 3. And this is 1 by 3, the whole square it is there. That only it is become 1 by 9. This 2 is written as it is. And 12 minus 2x, the whole square. These terms are written as it is. And here also dx to be written. Because we are concentrating now middle integration. Yes. Now, more any simplifications possible, we can see it. So this step it is written as it is. So we can see it now. So here we can see it divided by 1. Here 3 is there. But here 3 is there. But down here 18 is there. So cutting, here we are getting 6. That's what we have taken the LCM 6. So here multiplying with 24 it has become, because here 1 is there. Here 3 is there. This term is multiplied by 2. It has become 4. This term it is written as it is. So we have taken the LCM and weighted. So now the 6 and 4 put together, it has become 24. Here 12 minus x is there. Here also 12 minus x is there. Here 12 minus 2x, the whole square is there. but all the three terms 12 minus 2x is common. So we have taken 12 minus 2x is outside. So the leftover is 24. Here is minus 4x. Here minus. So 12 minus 2x, the whole square is there. So 1, it has come out. The leftover is 12 minus 2x. So this 1 by 24. This is 12 minus 2x. This put together 12 it has become. Here minus 4x. This minus minus it is becoming plus. So minus 4x plus 2x, it leads to minus 2x. So completely the middle integration and applying the limits, the simplifications, everything we did to make it comfortable to move the problem towards the next outermost integration with respect to x. Yeah, fine. Now we will concentrate the outermost integration, that is 12 minus 2x the whole square. So in this also, which is common, we can see it here. So we can see here in this term 2 is common. So we can, when we are taking the common 2, here we can notice it square is there. So 2 square, that means 4 we are taking out. After taking 2 from here, it is becoming 6 minus x the whole square. Here it is becoming 4. 4 by 24, it's nothing but 1 by 6. So 1 by 6, 6 minus x the whole square dx. This is written as it is. So 6 minus x the whole square, n is 2. We know it n plus 1, that is 3. Here also 3, but x coefficient is there, that is minus 1. That purpose this minus. So 0 to 6. So this 6 and minus 3 put together, it is 18, that is minus 1 by 18. 6 minus x the whole cube, 0 to 6. So minus 1 by 18. So upper limit is 6, that is 6 minus 6, we are getting 0. So now this is the formula minus, and x place we are putting 0. So we are getting 6 cube, it's nothing but 216. So the final result, so minus minus, it has become plus. So 216 by 18 equal to 12 is the answer for this particular problem. We will come to a conclusion of this volume of a region using triple integration. That is definition of volume integral. So this is if it is in the Cartesian form. So we concentrate in this video lecture the Cartesian form, that is dx, dy, dz, the triple integral 3 times we have to do the integration. Mostly we concentrate at taking xy plane, then the z is becoming 0. Using that concept, the innermost, the integral is taken with respect to z, and we did the problems. So for that, first we have taken tetrahedron. This is the conditions: x equal to 0, y equal to 0, z equal to 0, and the 3-dimensional. The plane x by a plus y by b plus z by c equal to 1. So we have did the diagram according to this plane, and only the xy plane, to understanding the level to increase, it is drawn separate. And one more problem also we concentrated, that is x equal to 0, y equal to 0, z equal to 0, and the plane is 2x plus 3y plus 4z equal to 12. Here also we extracted from this what is z, what is y, and what is the x, and we did the triple integration. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.